Okay, so now let's look at application of using these related rates. So let's look at the first word problem. And let me just read it through for you. So it says a manufacturer of handcrafted wine racks has determined that the cost to produce X units per month is given by C equals 0.2x squared plus 10,000. How fast is the cost per month changing when the production is changing at a rate of 12 units per month and the production level is 80 units? Okay, so let's go through and start writing stuff down and pulling things out. So it says a manufacturer of a handcrafted wine rack has determined that the cost to produce X units per month. So X equals the number of units produced in a month. And that cost function, C, this is equal to 0.2 x squared plus 10,000. It wants to know how fast is the cost per month changing when the production is changing at a rate of 12 units per month. So this is changing at a rate So I hear the word rate in there. So that tells me this is the derivative of my production. So production is changing at a rate of 12 units per month. So to me, that's telling me that dx dt, that rate of change, dx with respect to time, is equal to 12. Let's go back. So how fast is the cost per month changing? So we're really wanting to find cost per month changing. So we want to find dc dt. At a rate of 12 units per month changing when production is changing at a rate of 12 units per month, which we got down, and the production level is 80 units. So we're given that our production level X is equal to 80. Okay, so we know what we need to find. We have things defined and we have values for certain quantities. So we're going to go through and we're going to look at the derivative, taking the derivative both sides with respect to time. So the derivative of C, well, that's just 1 dc dt is equal to, the derivative is 0.2x squared. So that's 0.4 x dx dt plus the derivative of 10,000 is 0. So now we're just going to go in here and plug in our variables. So we have 0.4 times x. X where we're given was 80. dx dt we were given was 12 times 12. So the rate of change of the cost at those values. So 0.4 times 80. Well, I would ignore my decimal. So 4 times 80, that's 320. But move my decimal over once, that gives me just 32. All times 12. So 12 times 32. That gives us 384. So how fast is the cost per month changing when this is happening? It's changing at a cost of $384 per month. $384 per month. With the information we were given. The next example says the manufacturer that we just talked about that was doing those wine racks found that the cost and revenue are in dollars in 1 month are related by the following equation. So C is equal to capital R squared all over 450,000 plus 12,000. They want us to find the rate of change of revenue with respect to time when the cost is changing by $15 per month and the monthly revenue is $25,000. Okay, so find the rate of change of the revenue with respect to time. So we want to find the derivative of our revenue with respect to time, so dr dt. And this is when the cost is changing. So cost is changing, that's like a rate. It's changing by $15 per month. So we know that the derivative of our cost function, dc dt, this is changing in here $15 per month. And this is when the monthly revenue is $25,000. So we're given that our is $25,000. So we can go in here and we can differentiate both sides of our equation. So, and they're both with respect to time. So taking the derivative of C, that gives us dc dt is equal to, we can think of this as 1 over 450,000 times r squared. So let's just use the general power rule, bringing 2 down front. So we have 2r all over 450,000 times, we just took the derivative of revenue with respect to time, so dr dt. And plus the derivative of 12,000, which gives us 0. So we really don't need to put that plus 0. So we're just going to go back in and plug in what we know and what we are trying to find. So we know what dc dt is. That is 15 is equal to, well, 2 over 450,000. We can reduce a little bit. 2 goes into 450,000, 225,000. And we're given that R is 25,000. So we have 25,000 all over this 225,000. And dr dt, that's what we're trying to find. So dr dt. So this gives us 15 is equal to, well, 1,000 goes into both. And so we're left with 25 over 225. And so 25 goes into 225 9 times. So 1 over 9 dr dt. Multiply both sides by 9, and we get dr dt, the rate of change of our revenue with respect to time, is 9 times 15. So the revenue is changing per month by 9 times 15. So let me just multiply that out. $135 per month. So now we're given that the revenue and cost functions. So we're given that revenue. This function is equal to 50x minus 0.4x squared. So 50x minus 0.4x squared. And then we're given that our cost function is equal to 5x plus 15. And it tells me that this is in dollars, where X is the daily production and sales. Find the following when 40 units are produced daily, and the rate of change of production is 10 units per day. Okay. So let me just pull this out. So where X is the daily production, per day. And find the following when 40 units are produced. So we know what our X value is in this case. X is 40. And the rate of change of the production is 10 units per day. So rate of change, our production is X. So our rate of change, dx dt, is equal to 10 units per day. So we want to know what is the rate of change of the revenue with respect to time. So part A is find the rate of change of the revenue with respect to time. So in this case, we want to find revenue, rate of change, so dr dt. So let's just go through and take the derivative of both sides. So the derivative of r is dr dt is equal to the derivative of 50x, that gives me 50 dx dt, minus the derivative of 0.4x squared is 0.8x dx dt. Okay, so now we can just go in and plug in what we know. We know x is 40 and we know dx dt is 10. So the rate of change of our revenue with respect to time is equal to 50 times 10 minus 0.8 times x, which is 40, times dx dt, which is 10. So 50 times 10 is 500 minus Well, 10 times 40, that's 400. 400 times 0.8. Well, 8 times 4, that's 32. We would have had 2 zeros, but then this point here for the decimal moves our decimal over once. So we're just really left with 320. There's a decimal there. And so the rate of change of our revenue with respect to time is 500 minus 320, which is $180 per day. Part B wants to find the rate of change of the cost with respect to time. So same sort of thing that we just did, but this time we're looking at our cost function instead. So part B, find the rate of change of the cost. So we're going to take the derivative of C. So we know that dc dt this is equal to the derivative of 5x, which is 5 times dx dt plus the derivative of 15, which is 0. So we get dc dt is equal to 5 times the rate of change of our production, which was 10. So that's going to be the rate of change of our cost per day with those values is going to be $50 per day. And then the last part is asking us to find the rate of change of the profit with respect to time. Find the rate of change of profit. Okay, well, profit, this is equal to our revenue function minus our cost function. So our profit function is equal to, you need to go up here and find it. My pen's starting not to work. Let me just write it down. So profit is equal to our revenue, which is this 50x minus 0.4 x squared, minus, make sure you put a parentheses around that whole cost function because that negative has to be distributive. So minus the parentheses 5x plus 15. Sure, I wrote it down right. So let's go ahead and let's distribute this negative sign in here. And then let's combine like terms. So I get my profit is equal to 50x minus really a 5x. Well, that's going to give me a 45x minus 0.4x squared minus 15. So there's our profit function. And now we can find the rate of change of profit. So dp dt, this is equal to the derivative of 45x, which is 45 dx dt, minus derivative of 0.4x squared is 0.8x dx dt. And the derivative of negative 15 is 0. So we're going to go in here and we're going to plug in what we know. So we have 45 times dx dt, which we'll go up and find that what that value is in a second, minus 0.8 times whatever x was times whatever dx dt is. Okay, so x was 40, dx dt was 10. So plug in 10 wherever you saw a dx dt and 40 wherever you see an x, and then let's simplify this down. So we have 45 times 10. So that's 450 minus, I believe what that was 320, right? 400 times 0.8 is 320. So the profit's changing with respect to time at those quantities at $130 per day.